Hello, my dear friends. How are you? Hope you all are fine. So, welcome back to my channel MJ Makes Easy Edu Academy. So far, I have covered for you one physics topic, one maths topic, and today I am going to cover for you one of the chemistry topic, which will be basics for the classes 6th, 7th, 8th, 9th, and 10th. So I have started from the basics, from the ground, so that you all should follow from the basics. So without wasting time, let us start our topic, the matter. So what is a matter? So everywhere we look around, everywhere we see around, we see that walls, we see switches, we see the pen, we see fridge, we see the cane, we see the mobile phone. So all these is a matter. What is this? These all are what? Matter. So let me define what is matter. So matter is something which occupies space and has certain mass. So matter is defined as something which has mass and occupies space. So it is something which has certain mass and occupies certain space. So you might have studied regarding the states of matter. So I can write it as first one as solids, then fluids. Again, fluids are termed into liquids and gases. So generally we learn this one as three states of matter, that is solids, liquids and gases. So in updated one we have the fourth state of matter, that is plasma. What it is? The word plasma. And the fifth state of matter is called as Bose-Einstein condensate. Bose-Einstein condensate. And sixth is time crystals. So these are some states of matter in today's modern world. So let me define you one after the other all these states of matter. So now let me define what are solids, what are liquids and what are gases. So let me write here. First I am writing as solids, then here as liquids and here as gases. With the first step itself, you will come to know the solids, liquids and gases. So this is the structure of solids. What is this? This is a structure of molecules where particles are very closely packed. How they are? They are very closely packed. And if I take the structure of liquids, so they are little bit loosely packed compared to the solids. When we come to the gases, the molecules are very loosely packed. How they are? They are very loosely packed. By these three structures only we'll come to know that here the molecules are, the particles of solids are very closely packed, and whereas here loosely packed than solids and very loosely packed than somewhat closely packed than gases. So I can write here, they are particles are closely packed. Here particles are loosely packed. Here I can write as particles are very loosely packed. Very loosely packed. And next, one more term I am going to define you, that is intermolecular space. So what is intermolecular space? So I'll show you in all these three diagrams the intermolecular space. In solids, you can find a small gap between these two molecules. In liquids, you can find a small gap between these two molecules. In gases, you can find a small gap between these two molecules. So the space between two molecules is called as intermolecular space. What is called? It is space between two adjacent molecules. Adjacent molecules are particles. Molecules are particles. Is called as is intermolecular space. What is intermolecular space? So here the intermolecular space is very small, almost all negligible. How it is? Very small or almost all negligible. So here, so very small. Here more than solids and less than gases. Here intermolecular space is very large. What is? It is very large. They are very hard. They are very strong and hard. How they are? They are very strong and hard. They are not strong. They are also not strong. They are also not strong and hard. These have definite shape. I can write here, they have definite shape. They have definite shape. They don't have definite shape. They also don't have definite shape. So solids will be having a definite shape. See this box, see this cap and this pen, they have a definite shapes. But whereas liquids and gases do not have definite shape and they take shape of container. What they take? They take shape of container. So liquids and gases will take the shape of the container. Hope you understood the three differences between solids, liquids and also gases. So one more last property which is very important for us, that is solids cannot be compressed. It means we can reduce its size by applying some outward force or outward pressure. So solids cannot be compressed, liquids can be compressed up to some extent, but gases can be compressed largely. So liquids and gases will have the property of compressibility. So regarding compressibility, we can discuss any other time. Now, examples of solids, liquids and also gases. So solid examples are many. I can give as pen, diamond, etc. Liquids I can give example as water, acids. Gases I can give many examples like oxygen, nitrogen, neon, etc. These are some examples of solids, liquids and gases. So now, without wasting time, let us go to the fourth state of matter, that is plasma, and the fifth is the Bose-Einstein condensate, and the least is time crystals. So our next topic is plasma. So what is plasma? The fourth state of matter. The fourth state of matter. So when can we form plasma? When plasma is formed. This when plasma is formed. So let me make it very easy. If we heat liquid, it changes to gas. When we heat gases more than 3000 Kelvin, it becomes plasma. What it becomes? It becomes what? Plasma. I can also define you in some other way, that is, it is a soup of positively charged particles and also negatively charged particles. Right? So, example for plasma is the lightning and the gases present in the neon and fluorescent lamps. And one more information about this plasma, that our earth is also immersed in a huge plasma, in a very big plasma, and that plasma of earth is called as ionosphere. Right, children? Okay, hope you have understood this topic. So regarding this plasma, we shall have a separate class, and now let us discuss about Bose and Einstein condensate. So what is the fifth state of matter? That is Bose Einstein condensate. So to form plasma, we have heated it. In order to get this Bose-Einstein condensate, we should cool to very low temperature, a hair above the absolute temperature, which is very difficult to obtain. When we cool to this much temperature, a new substance which is not solid, which is not liquid, which is not a gaseous substance, a new substance, that is Bose-Einstein condensate, will be formed. Almost all absolute zero, we should cool it. Very difficult to achieve that temperature. So at that time, we find this Bose-Einstein condensate. So in this name Bose, I think you feel somewhat familiar. So a physicist from India, Bose, had written a letter to Einstein that I have made some calculations on the dual nature of light. I have done some mathematical formulas, mathematical calculations on the dual nature of light, which was previously discussed by the scientist called as Louis de Broglie, that light has dual nature. One is particle nature and another one is wave nature. Here, Bose also made some calculations on the light particles, which sometimes behave as a particle and sometimes as a wave, which are holding the light atoms. Then Einstein, in those days, maybe around 1925, Einstein started thinking more about this, and he thought that there may be something useful which can be made a new matter. So slowly he developed a new charged particle, that was Bose-Einstein condensate. So when these molecules are very cool to very low temperatures, these particles look like these particles. Slowly they change to become like small curves or small waves, or you can say this is a small packet of energies. And what they do, after some time, they get overlapped. What they get? They get overlapped, and finally, what we see that they lose their identity. They lose their identity, and later we form Bose-Einstein condensate. Right? To explain about these time crystals, let's take an example of diamond. So the diamond is a substance which has the same properties or behaves as same structure. But when we come towards the examples of time crystals, they cannot maintain an equilibrium. Hence, they will be moving continuously in motion without maintaining an equilibrium. A small motion also can disturb them. You can see some example or you can see the video and understand how the molecules of this time crystals behave. Normal molecules will be behaving just by transferring energy from one molecule to the other molecule, and hence the energy completes. But whereas the time crystals will be having an elastic molecules which will be vibrating continuously. So this was the matter and different states of matter, and having a brief explanation on each and every topic. So in next classes, we will discuss about the atom, molecules, compounds, chemical reactions, and many more. Then slowly we will enter into the atomic structure. Hope you have understood this video, children. If you like the video, please like, share, subscribe, and don't forget to comment. And also press the bell icon so that you can be notified. Thank you. Have a nice day.